So you'd like to make the Earth a better place to live, so you start by thinking about the turtles. To save the turtles, you'll have to protect their ocean ecosystems. To keep those ecosystems free of debris, you should reduce your consumption of plastic and recycle what you do use. But in order to recycle your plastic, you need to find out what all these numbers mean. 1 through 7? Recyclable or unrecyclable? What exactly is plastic anyways? And why are there so many different types? To answer those questions, you're going to have to learn a little chemistry. Before we get into recycling, let's talk about what plastic is in the first place. No matter what form the plastic is in, it always consists of a basic chemical structure. That structure is a polymer, a repeating pattern of smaller units called monomers. The identity of the monomer is a large contributor to the various properties of the plastic: hardness, heat resistance, brittleness, and so on. Plastics can be hundreds of monomers in length, giving them a special durability that underlies their persistence in the environment. To categorize plastics based on their monomers, we use the Resin Identification Code, those little numbers on plastic products that I mentioned earlier. Let's look at each in turn. 1. Polyethylene terephthalate. Polyester fabrics, clamshell packages, plastic bottles. Widely recyclable. 2. High-density polyethylene. Milk jugs, playground equipment, plastic chairs. Also widely recyclable. 3 is polyvinyl chloride or PVC. Pipes, flooring, siding. Usually recycled by national initiatives rather than through curbside pickup. 4. Low-density polyethylene. Plastic bags, plastic wrap, and flexible plastic components. Not usually recycled by curbside programs. 5. Polypropylene. Automobile parts, food containers, plastic currency. Pretty commonly recycled. 6 is polystyrene. Packing peanuts, disposable cutlery, and CD jewel cases. Not usually recycled. Finally, 7 is other. Nylon, biopolymers like polylactic acid, and other miscellaneous plastics. Also not commonly recycled. As you can see, there's a wide variety of plastics used in both consumer and industrial settings. Several methods of recycling them exist, which we could demonstrate using PET, which is number 1 on our list. Chemical recycling, where the polymer is broken down into its constituents. In this case, terephthalic acid and ethylene glycol. Both compounds can be used to manufacture more PET, as well as other materials. Mechanical recycling, where the plastic is shredded or otherwise broken up, maintaining the chemical structure, but forming new products from old ones. And incineration, while not recycling per se, where the plastic is burned in a controlled environment to produce energy. Because PET is only composed of carbon, oxygen, and hydrogen, its combustion products are mainly carbon dioxide and water, which makes it reasonably safe to incinerate. Depending on the feasibility of these methods, some plastics are more commonly recycled than others. For example, recycling polystyrene is not very cost-effective due to its low density. Even a whole box of packing peanuts doesn't weigh very much. However, you should always ask your local recycling service which plastics they accept. It is your responsibility to be an informed citizen, and their responsibility to safely collect and recycle these environmentally damaging plastics. Reduce your initial plastic consumption, reuse what you can before disposing of it, and recycle your plastic waste correctly. Pay attention to those numbers, so you can keep ecosystems clean, save the turtles, and make the world a better place. That is why you should care about plastic. If you like this video or learned something about organic chemistry, like and subscribe to my channel. Also, visit my page on Facebook and check out my website on the screen. If you're willing, please consider donating to my Patreon page, where your support challenges me to continue creating these videos for all of you. Thanks for watching.